Hello, ladies and gentlemen. Welcome to this section, Building an IoT Solution. This is a really exciting section in terms of the takeaway and the content. In this section, we're going to take a look at how internet works. We're going to take a look at the different communication protocols used in IoT device communication. We're going to get you started with some basic and fundamental electrical and electronic components like resistors, capacitors, relays, regulators, and so on. We're going to get started with the Arduino. So we're going to set up and test Arduino Uno. We're going to set up and test the ESP8266 Wi-Fi module. This is a critical piece in any IoT development. We're also going to set up and test some sensors. This will enable you to build IoT prototypes and move forward. Let's take a look at the first topic, how internet works. In this topic, we're going to take a look at the communication from your edge device to your server and back. We will also take a specific example of searching for Google. All right, let's get started. The first question is, how is the internet set up? How are we able to send a message from, let's say, North America to Australia? The basic fundamental hardware is through cable. The messages go through cable. That's right. Of course, there are many more hops and different technology, and even satellites and wireless communication could be involved in the meanwhile, but the main communication happens through the cable. Now, this cable is an optical fiber cable. This is a special cable made up of small glass tubes where the message is sent in the form of light, and they can travel at the speed of light. So they can travel 186,282 miles per second. So that's almost going from New York to Australia and back in less than quarter of a second. The bandwidth these cables can carry can be from hundreds of GBs to many TBs per second. So they can carry a lot of data in one go. Of course, there's a lot of more information about how these things work, the technical details and so on, but this is just to get you started. Let's take a look at how all of this works from a device point of view. First, let's take a look at the different components, and then we'll get started with the explanation. First is you have an IoT device in the form of Arduino plus an Ethernet or Wi-Fi board, and you have a couple of sensors. Let's say, for example, we're going to call this an IoT device. Then you have a router, you have an ISP provider, and you have a Google server which you want to communicate with. Now let's talk about the role each of these components are playing. So obviously your IoT device is doing a specific function with sensors, it's collecting data and it's communicating to some remote server and so on. The router is doing the job of connecting your IoT device with the ISP. Your internet service provider is doing the job of connecting your router to the World Wide Web, and Google server is doing its own job. Now what we need to establish is communication between your IoT device and your Google server. Now keep in mind that your IoT device is connected to your router via Wi-Fi, your router is connected to the ISP, and the ISP is actually connected to the World Wide Web, and eventually it locates the Google server. So for your IoT device to communicate to the Google server, it first has to communicate with the router has to communicate with the ISP, and the ISP actually communicates to the server, and the whole way back to your IoT device when your Google server responds. Considering that there are billions of devices connected to the internet and millions of host names, and there could be many devices connected to your local network, is highly critical to have a very strong addressing system, and it needs to be unique. There are two kinds of addresses used to solve this puzzle. One is called the MAC address, Media Access Control, and another one is called the IP address. Now to understand this better, let's take a very simple example. Now let's say that you want to ship a box from California to Kentucky. So these two are physical addresses or physical assets. So it has a physical address in California and it has a physical address in Kentucky. This does not change. You call FedEx to do the job for you. So FedEx comes and takes your source address, target address, and it gives you something called the tracking number to track your package. Now this tracking number is a temporarily created unique number which will allow you to track your package wherever it is. Now keep in mind that this tracking number is only valid till the point that this package is delivered to your target, and then this will be not valid and it can be reused. Wherever you see a MAC address, you can substitute this with the actual physical address of the house, because each and every device has a MAC address, and this is burnt into the device by the manufacturer. This is unique in nature. So whenever a device needs to reach another device, whether a computer, a router, or a client, all of them are going to be looking for the MAC address. Now, to send the package across, it uses the TCP/IP protocol. And to do that, it uses something called the IP address. Now, this is very similar to your tracking number. Now, let's take a look at this example. So you have the ISP provider, there's a router, you have an edge device. Okay. So your ISP provider, which basically is your internet provider, remember that there's a cable which is provided by your ISP, and then you hook that cable into your router. That's exactly what this cable is. This ISP provider gives you a tracking number, which is a public IP. And this public IP is dynamic in nature, and it creates a new IP every time you create a new session. You can also opt for a static IP when you want to host a server and the name and the address of the server cannot change. So that is how your ISP is going to communicate to the router. So router and ISP know each other. Now, you could have multiple devices connected to your router. So that is why your router has a local IP. In this case, it is 192.168.1.xxx. So technically, you could have 254 devices connected to this router. So for example, if you had 9 devices connected to the router, then the 9th device would be 192.168.1.9er. So all the messages sent from this IoT device number 9 to the router are sent over the IP address 192.168.1.9. Now let's try to simulate the example of looking for Google. So the message is created on the Arduino plus your Ethernet or Wi-Fi board, and it comes to the application layer as a get HTTP request, and then it goes to the TCP/IP layer. The message is created with the source address, with the target address, with the message, the length and other parameters, and a port number is also attached. Then this is sent to your router. So now your router knows who is sending this message, where it has to go. Then it stores that information in a location. Then it passes this information to your ISP provider. It says that this is the target destination, and for your ISP, the source is your router, not your device, because your ISP is only talking to your router. So the ISP now goes to the World Wide Web, finds that IP. In this case, the Google's IP is 74.125.224.72. It goes, communicates with the server, it delivers the get HTTP, it gets the response. If it's success, it's going to be 200 and the message. So it's going to pick up the message, come back and deliver it back to your router. Now when the router gets this message from the ISP, it knows that this was sent by the 9th device connected to the router, which communicates from 192.168.1.9er. So it knows that this is waiting for the message, and their router delivers the message to the 9th IoT device, and then the communication is terminated. So this was a quick example to get you started understanding how the internet works. In the next video, we're going to be seeing what are the different IoT communication protocols and how to use them.